We're getting near the end of the show, and I promise I give you guys a problem. And here's the problem. I believe that with these kind of random interactions, if you have a big planet over here and a little projectile coming from it from this direction, that it's going to bounce off like that, or it might bounce off like that, or it might bounce off like that. Oh, if I come in pretty shallow, it's going to bounce off like that, isn't it? I believe that if you look at it from a far-off perspective, that so long as you do collide with this big sphere, it's just as likely to go off at 45 degrees or 60 degrees, or I haven't drawn that good. This one should have gone off. It's just as likely that it would bounce off at 90 degrees or 45 degrees or 120 degrees. All of these angles have an equal probability as being the consequence of the collision. This is not a trivial fact. It's not obvious. I believe it's true. And I'd like to work on this next time, on the next show, to show that the average consequence of this kind of collision, am I making the problem clear? I don't know if I am. That your probability of what your reflection angle is going to be, it's got equally good chance of going off in any direction. So that if there was a shower of projectiles coming in towards this thing, that they would be scattered off in such a way that wherever you stood, you'd be getting hit by an equal shower of reflections. Is that clear, what I'm trying to say? I'd like to prove this next time, and I'd like to leave it for you as a puzzle to think about. And with that, I think we got time to do our final song of the show.